So my plan in this video, two things. I'm going to show you how to do long division for polynomials, and I'm going to kind of harken back to your days of 4th grade division and try to show you my best how they're pretty much the same thing. Now granted, you haven't done this since the 4th grade, so I expect you to be a little rusty on this, but hopefully you remember it well enough to be able to apply the same ideas to this. The second thing I'm going to talk about is what it even means to take a polynomial and divide it by another polynomial, because it is kind of a strange concept if you ask me. So let's start over here. When you had to do something like this, what you were taught as a kid was to figure out how many times this number on the outside went into this number here. And whatever that number was, you would put that up above. So 3 would go into 4, one time, so that one will go up here. And then you would take this 1 and multiply by the 3, put this answer here. You would then subtract 4 minus 3 is 1, and the next thing would come down. And you'd kind of start all over again. 3 into this number, how many times? That answer would go up here, so that'll be a 5. 5 times, then you do 5 times the 3, would be 15. You'd subtract, bring the next thing down, and start the process all over again. 3 into 7 would be 2 times. 2 times 3 is 6. Take away 1 is 1. And you'd probably write remainder 1, but what I hope someone taught you is that means you have 152 and then 1/3, where the remainder goes on top and the divisor goes on the bottom. And if you had any doubts about the accuracy of my answer, you could take 152, you could multiply the answer by 3. So take this, multiply it by this, and then if you add that 1 back in, you would end up getting this 457. Polynomial division is basically the same thing, it just looks crazy. So just like we look here and here, we're going to look at this, always look at this first term here. Don't even worry about that plus 7, and then we're going to look here as well. And we need to basically ask ourselves the question, just like over here we said how many 3's go into 4, the question is what would I multiply 2x by if I wanted to get 10x squared? And this is a question myself I break into pieces. And I think when I first learned this, off to the side I would literally write down 2x multiplied by what is 10x squared. I would definitely think that, and I'd probably even write that down. So I'd be like, well, if I want to get to 10 and I've got 2, I'll be multiplying by 5. If I want to get up to x squared, I've already got an x, I just need one more x. So that's what I would multiply 2x by to get 10x squared. That kind of corresponds to this 1 here. That in this problem, the next thing you did was take the number you put up here, and you multiplied it by what was on the outside. And you put the answer to that product here. That's what we'll do here. We'll take this 5x multiplied by this, and we'll put the answer here. So that's going to look kind of like, well, it'll look exactly like this. The calculation I'm going to do is going to be take that 5x, multiply it by 2. Now what I just wrote down in orange, I normally don't write that down, but that's what I'm doing mentally. I'm doing 5x times 2x is 10x squared. 5x times 7 is 35x. And now, the one thing that you might screw up is, that's easy to forget, is that we subtracted. The next thing to do is subtract. We did 1 times 3 was 3, and we subtracted to get a 1. We need to subtract this. And because this is multiple terms, there's this little annoying rhyme that goes through my head, which is that I draw the line and change the signs. I will draw a line here, and whatever these signs were, here and here, I'm going to change them. So this will become negative, this will then become negative, and now I'm going to go ahead and add straight down. These will and should make 0 based off of what I picked. And then these guys combine to make an 8x, if my algebra is, or my arithmetic is correct. And then just like over here where the 5 popped down, this is going to pop straight down. And I'm right back to square 1. I'm looking here, and I'm looking here, and I'm saying how many 2x's go into 8x. And as a youngster, what I did literally was I probably underlined this, and I underlined this. And off to the side, or in my brain, I thought 2x times something is supposed to be 8x. What could that something be? I need the 4 to get up to 8, and I need an x, and I've got an x, so that's going to be fine. So my next order of business is to take that number that I put on top and multiply it by this thing on the outside. So I'm thinking mentally 4 times 2x plus 7. And that is going to become 4 times 2x is 8x. 4 times 7 is 28. That's a weird looking 8. And then we're going to draw the line and change the signs. Draw this line, change these signs. These will cancel. 32 and negative 28 make a positive 4. And now I might go and say, hey, what can I multiply 2x by if I want to get 4? And because this has an x and this doesn't, you can't. Like I can't multiply 2x by anything to get 4. So this becomes like my remainder. So depending on what Alex has you do, and it changes from assignment to assignment, you might do remainder 4, or you might do, and I know you definitely do this more often, it'd be, where can I write this? I erased some stuff. I could take, might do, made my pen too thick, as 5x plus 4, and then take that remainder and put it over the divisor, 2x plus 7. So that's an acceptable answer, and probably one that Alex will ask for. Another acceptable answer when Alex asks for it is to just say 5x plus 4 with the remainder of 4. So very, very similar to the division you did long ago. Keep that in mind as you go. Keep track of the differences. As always, be patient with yourself, and you will definitely get it figured out. Good luck.